Hi everyone, this is Kerim Baran with SolarAcademy. I have with me today John Drummond from Chint Power Systems. Welcome, John.
Thank you, Kerim. Nice to be here.
Yes, today we are planning to talk about Chint's higher voltage products and solutions specifically for the utility segment of the solar inverter space. And with that, maybe talk a little bit about, John, your background. When I looked at your LinkedIn, I've noticed that you've been with Chint Power Systems for almost a decade here, mostly in the US. And I remember the early days of Chint and how you guys made such a strong entry in the CNI space. And now hearing about the utility segment focus and really learning more about Chint Power Systems as a company has been enlightening for me. So it would be great if you can tell us a little bit about your background and then maybe a little bit about Chint's global footprint.
Yeah, sure. Yeah, thank you again for having me. Yeah, I've been with CPS America for just a little over 8 years now. And prior to that, I was with two other inverter manufacturers. I kind of cut my teeth, so to speak, in renewable energy in the mid-90s when I worked for a wind turbine manufacturer. And at the time that I was hired, they were doing what they referred to as non-wind projects. This was kind of a little pet project under the engineering director's umbrella. And I reported to the electrical engineering department. That company ended up getting absorbed by, two other manufacturers eventually. And my roles with those companies started out that I was basically a lab technician and then worked into a program management role, eventually got involved in compliance testing and new product development, applications engineering, and so forth. And then moved to Chint in the fall of 2015, when there was this kind of shift in the industry to use string inverters predominantly for CNI applications. But now we're seeing them more and more being used in, as you mentioned, in utility scale applications. So string inverters to kind of, combat the kind of historical premise that a central inverter was the way to go for utility scale projects. Yeah.
So with that, can you tell us a little bit about Chint and how it started overseas and came into the US? What are the various different things that they're known for, maybe in its home country versus in the US versus other markets?
So Chint Group is a global company. They are like the GE of Asia, I'll call them, something like that. They make just about everything under the sun electrical. They make low voltage electrical equipment, circuit breakers, contactors. They do building and automation. They do transmission and distribution equipment. I mean, they basically do everything. And they also have a solar energy line of business. So they have CPS America, which is the company that we work for. And then there is a CPS, a Chint Power Systems Asia. And we manufacture two different products based on, where these products are sold, the markets are sold into. So here in North America, it's UL listed string inverters that comply to all the standards that are required here in North America. And then, of course, the other products have IEC listings and Australian listings and so forth, where they're sold into those markets. Yeah.
Got it. And there's also a big, I think, $1 billion plus transformer business along with all the inverters.
Yeah. So Chint Group is like a $14 billion, corporation. And as I mentioned, we fall under their renewable energy business. So you may have heard of Astronergy PV modules. That's a Chint Group company. And then CPS, Chint Power Systems America, is a Chint Group company. So we are fully financially backed by this parent company, but we are somewhat of a separate entity in terms of, the business here in North America. We're based out of Richardson, Texas. That's our legal office location, just north of Dallas. And then we do have offices in California, where I work out of, and then also in New Jersey.
My exposure and introduction to Chint happened when I used to work with Civic Solar, my prior company, as a distributor. And I remember it as an inverter provider for the CNI space. But now, based on our recent conversations, I'm aware that you guys are expanding beyond that, expanding into full solutions. Maybe you can tell us a little bit about like why this transition is happening in your focus and how things have evolved as it relates to the products that Chint was selling in the US solar market, and how are, yeah, let's talk about those higher voltage products and
Yeah, yeah.
what's driving the need for all of that.
Yeah, so let's start back. So the North American business was really started about 2012, and that
Mhm.
was bringing transformerless string inverters to the market here in the US. This was a change that had already been adopted in areas like Europe, in Germany. So there
Mhm.
was a code change in the National Electric Code here in the US for what they was referred to as ungrounded PV systems. So you
Mhm.
no longer had to use inverters that had an isolation transformer to isolate the DC from the AC. And the PV array was no longer grounded. Typically, everything had to be grounded, either DC positive or DC negative. And with the advent of string inverters, we introduced that to the market, and we had 14 and 20 kilowatt models were kind of the first ones that are brought to the market, really aimed at CNI, just kind of early adoption of this type of product in these markets. And those markets have essentially grown, and we developed other models. We now have a 25 kilowatt through a 60 kilowatt aimed at CNI. These are 1,000-volt DC products. But the old 14 and 20 were only 600-volt DC models. But then as the code cycle changes and the open circuit voltage that's allowed to be used for PV systems, evolved, then it became 1,000-volt. So there was a lot of people that were using these for commercial rooftop, big box stores, but also using these 1,000-volt inverters for what they referred to as small utility scale applications, where they were grouping, say 30 or 40 inverters into a single step-up transformer through a switchboard and so forth. And we started developing, and Chint has always tried to stay on the forefront of innovation. We have things like separable wire boxes in our CNI products that are really advantageous for installation. If there ever was an RMA event, you simply open up the disconnects, put on your lockout tagout, and then wait the 5 minutes for any energy to discharge, remove what we call the power head, which is really the power conversion portion. But you don't have to remove any cables or safeguard them or any of that kind of stuff. So it really speeds up the process, and a lot of our customers really like that. So we decided that we wanted to kind of get into the utility scale market a little more, and that was around the time when PV open circuit voltage went from 1,000 volts to 1,500 volts, specifically for ground mount, because the maximum voltage for buildings is now still at 1,000 volts. But for a ground mount or even a carport canopy, which doesn't qualify technically as a building, you can put 1,500 volts on it. So the advantage there is that you can play the old Watt's law. So as voltage increases for the same power level, your current's going to go down, meaning your conductors can be sized less. Or
So
if you just
save on the BOS.
yeah, or if you
Yeah.
exactly, or if you keep the same current rating and go to a higher voltage, then you get more power. So it's kind of a win-win there. So we started developing 100 and 125 kilowatt inverters at 1,500 volt DC string inverters. Again, these are still transformerless designs. And I remember looking back, several years ago when a 100 kilowatt inverter was a central inverter, and you think about the power density that's all packed into this 100 and 125 kilowatt inverter. It's the size of a suitcase, rather than, an industrial refrigerator or whatever it used to be.
Right.
Yeah. So we did the same thing in terms of increasing the DC voltage, which was allowed by code, by increasing the AC output voltage, or what the inverter interconnected with. So we went from 480 volts three-phase to 600 volts three-phase. Very common in Canada. there's a lot of systems, a lot of older systems also here in the US that still have 600 volt 347Y, source grid sources. So we did the same thing on the AC side by making an inverter that intertied at a higher voltage. That meant that the conductors would get smaller and so forth, and it's a win-win. And we incorporated those features like separable wire boxes into those products, so they were easy to install and easy adapted. So kind of moving on and keeping that same theme, we introduced our 275 kilowatt inverter, 1500 volt DC, but it has an 800 volt intertie, three-phase. Yeah. So again, a win-win there with keeping a small package size in terms of a string inverter. It weighs less than 200 pounds. It's it's still the size of a suitcase, but you get all the benefits of the increased voltage, the benefits of string inverter, which I can go into a little more as we talk about utility scale applications. But one of the kind of hurdles that our customers were getting was finding balance of system equipment that had these voltage ratings and were listed for this particular voltage rating. Historically, you could get equipment that was listed to 600 volts, but it was like UL 508 or 408. I'm trying to think of the exact listing for the product, but it only went to 600 volts, and there was a disconnect between the inverter has to work at an operating range of 110% to 88% of nominal voltage, right? Which meant for a 600 volt nominal, you had to be able to operate at 660. Well, where do you get equipment that's listed to 660 volts? So some manufacturers, some third-party manufacturers were offering things like switchboards or molded case circuit breakers that were dual listed to UL and IEC. And IEC went to 690 volts AC. But it was still a little bit difficult to come by. So what we've done at Chint Power Systems America is, rather than just being an inverter manufacturer, we are now a solutions provider. So we have additional balance of system equipment that we can offer. One being our what we call our switch box, which is a 3-in-1 combiner with a fuse disconnect. And then we also have what we call our breaker box, which includes molded case circuit breakers where you can combine up to 3 275 kilowatt inverters into a single circuit. The switch box version 1 and version 2. So version 2 is just a little bit different than version 1 in that it's turned 90 degrees. This was some customer feedback that we incorporated into the design. And I could probably pull up some pictures and show you the inside of the switch box. So I will share my screen here and show you a little bit of the switch box. So this is these are some pictures that we showed this product at RE Plus in Las Vegas back in September. And this is a disconnect switch with 1,000 amp fuses and bus bars that accommodate the conductors for the combining the inverters into a single output circuit. This product was UL listed to 1741. I should say listed to the UL 1741 standard with 3 275 kilowatt inverters. And it went through all of the abnormal testing for short circuit, voltage spikes, every kind of abnormal that you would introduce when you're doing product development and you're going through certification testing. This product was evaluated to, and it was found that by testing the product with the inverters, so this kind of combined solution, that the response, the self-protection response of the inverters essentially mimicked having individual circuit protection for each inverter, and that it wasn't needed. this was, kind of a innovative feature that we came up with and tested and evaluated and got the certification for. So this product has been used for quite a few projects. There's been a ribbon cutting just about a month ago for a project in Montana that was a 105 megawatt DC that used the 275s and used this DC switch box arrangement. However, there is a little bit of pushback because when you look at these large utility scale projects, there is kind of a line in the sand that's either over 5 megawatts or under 5 megawatts. And National Electric Code Article 690 defines a large PV system. They don't call it utility scale. I think that's just a industry slang, but they define that line in the sand as at 5 megawatts. And anything that's over 5 megawatts under Article 690 is essentially an engineered design, stamped and approved. However, some of the requirements are a little more lenient, where you don't have to follow all of the quote rules of the National Electric Code because it's quote behind
Buildings, because they're bigger applications.
they're bigger applications. They are quote behind the fence.
Yeah.
There's a lot of
They're out on the field somewhere, not on a building next to people.
exactly.
Yeah.
However, if it's less than 5 megawatts, like you'll see, projects that maybe community solar that's at 2 megawatts or something like that, then you start getting scrutiny by AHJs that say, hey, well, this doesn't quite meet the code. What about overcurrent protection, Article 240, so forth. So we developed what we refer to as our breaker box. And let me pull up that picture. I'm sorry, let me find it first. I'll share it with you. I apologize.
And this is for your less than 5 megawatt solutions, basically.
Exactly. So this does the same function. It is a 3-in-1 combiner, so it does the same function as the switch box. And it includes 3 250 amp molded case circuit breakers. These do have a 50,000 amp interrupt capacity. And this meets the requirement for having individual circuit protection for each inverter circuit. So at the bottom here, I don't know if my mouse is showing up, but at the bottom of this enclosure, where you're seeing the molded case circuit breakers, that's where the output of the inverters would attach to. And then the combined bus bars would be the output up to the step-up transformer, the pad-mounted transformer in this case. So this product is also UL 7041 listed. It's a 3R enclosure. So you can see it's got vents on either side of it. It does come with surge protection, shown on the left side there. And this product would meet all of the requirements for the less than 5 megawatt applications. And I will share a document here as well. So I'm hoping you're seeing the slide deck that's a PDF showing some design options. Yeah, okay. So this was a brochure that we handed out at RE Plus that shows some applications for our 275 kilowatt inverters. And these diagrams are really for, reference only, and we can work with your design team, independently to work on the details. But what we've done, everything with a green leaf are products that are available through CPS. These are the string inverter starting on the left, and I'll zoom this in a little bit so your audience can see. So this is a kind of utility scale application design option where you've got 3 275 kilowatt inverters, 800 volt output, that are combining with our AC breaker box that I just showed. And then you can use the fuse disconnect with a single input. You don't have to use all 3. The bus bars are rated to carry full current. So this would be, perfect for an application where you've got a disconnect requirement in a line of sight. then the another option is to just use this, use a third-party switchboard is
Yep.
another option. Again, there's no green leaf here, so this would be supplied by somebody else. And then for behind the fence option, which I started with the discussion with, where you're just using the 3-in-1 switch box, we call it, which is the fuse disconnect. This is another option. So this again would be the behind the fence Article 690 design option. And then these solutions would be for utility scale and CNI, or when we say CNI, it's less than that 5 megawatt line in the sand.
John, I
Yeah.
have a question about these various different designs that you just show. In terms of when it comes to procurement for these various solutions, and considering that now we are in November 2023, what is the current lead times in terms of availability of
Yeah, great question.
products?
Yeah, so part of the when I mentioned the hurdle of acquiring 800-volt equipment and listed equipment was also just availability.
Yeah.
You might be able to get it, but is it available now? Is it available in a year, or so forth? We have decided to manufacture these products, make them available. They are in stock. It's a 4 to 6 week lead time for our balance of system equipment, and I mean the breaker box and the switch box. We also offer skid mounted transformer solutions, and those have a 26 weeks lead time. So not quite a year that you're hearing from other transformer manufacturers. Sometimes you're hearing more than a year. We can provide the transformer. It's a 34.5 on the high side and 800 volt on the low side secondary in a 26 week lead time. These transformers are also available with different vector groups. So we have essentially a configuration sheet that you can fill out and decide which vector group you want. We also are starting to offer transformers that are in the like 2.5 MVA size. The previous one that I mentioned is a 4.2 MVA.
This is
So
so
yeah,
key. I feel like this is so key to the current energy transition, because I was recently listening Elon Musk podcast. I think it was on Lex, and he was talking about how transformers, like it used to be the chips were the bottleneck a year ago or so, and now transformers are going to become the bottleneck because of all this increasing electrification and the electricity demand that comes with it. The bottlenecks are always they seem to be happening around the transformers. And
yes, yes,
great that you guys have that
yeah. Now,
advantageous
granted,
lead times.
The design cycle for a utility scale project is much longer than a CNI application, right?
Sure,
CNI
sure.
you can do in a few months, get your permitting and so forth. That typically a utility scale project will take, years, if not at least 18 months or 12 months. But that through CPS America you can get equipment quickly. So, if you start to break ground, you can at least do things, get things rolling ahead of time, and a much faster rollout than traditional. Yeah.
Well, thank you very much for all this depth and wealth of information you shared with us, John.
Yeah. Yeah.
Anything else we want to cover in this call?
Well, we had talked about the advantageous aspect of string inverters, and maybe kind of a string versus central argument.
Yeah, right.
Yeah.
Let's
So
dive into it. Yeah.
okay, so historically, utility scale projects have used central inverters. And when I say a central inverter, I'm talking about a big skid mounted, requires a concrete pad to be installed on. Oftentimes a huge equipment, a big flatbed
Size of
lowboy
a
truck.
car. Yeah,
Yeah,
or
a
bigger.
crane.
Yeah,
Yeah, as big as a car, right? Exactly,
yeah,
if not
sure.
bigger.
Yeah. Yeah.
Um, and that kind of seems like that's just the way it's always been done, right?
Right, right. I
You're
remember that was the case a decade ago when we were, or
yeah,
maybe 12, 13, 14 years ago.
and
Or
central
19.
inverters went from, like I said, from many years ago, from a big central inverter was a 250 kilowatt or a half a megawatt, now they're like 5 megawatts in, a central inverter. And
Yeah.
and for some projects that might make sense.
Mhm.
You've got to have a nice level pad area. You've got to make sure your row spacing can accommodate the vehicles and equipment to get in there with that kind of stuff. But what if you don't quite have that? What if you've got some complex terrain that's not flat, it's not square shaped, it's not a big perfect rectangle? You can use string inverters, and string inverters can essentially be deployed everywhere that you have a DC combiner box, right, for your central application. So you can distribute them out in the array, and then run your AC runs back to a central location. But what might happen is you might have some AC losses in your conductors. And if you take the kind of central inverter topology of placing a central inverter near the pad mounted transformer and running all the DC to it, you can do that same thing and mimic it with string inverters. I don't know what manufacturer it was, but they coined the phrase virtual central, right? Where they're taking string inverters and grouping them together to mimic the central inverter. And with that kind of design approach, you get what's referred to as free DC voltage drop, because you haven't done your power conversion yet, right? So you can upsize the array to a higher loading ratio, and then still, if there's any losses, that happens on the DC before it gets to the inverter, and then you can convert it from DC to AC at that kind of central location. However, also with string inverters, you're going to get multiple MPPTs, right? So not just one inverter doing all the power conversion. You're going to get a lot of individual little workhorses that have multiple MPPTs. So you're going to reduce your mismatch losses of the array. So you've got a win there. And you've got perhaps better system uptime. So if there's a problem with an underproducing inverter or a complete failure, it's going to be a fraction of the downtime, right? And they're easier to work on. There's no sophisticated spare parts in a string inverter. There's essentially DC fuses maybe, and some fans or something like that. I mean, those are really the only consumables, maybe a surge arrestor. Whereas in a central inverter, you've kind of got more sophisticated equipment inside. It also requires, a guy in a spacesuit to come in and work on it. Maybe a really experienced, specialized engineer, rather than, some easy low cost labor to go in and swap out an inverter.
Yeah.
And as I mentioned, it can be done in minutes rather than hours, in some cases. Just the ease of handling a string inverter. Yeah. So there's more trade-offs I can go into a little bit more, but I mean, that's kind of one of them. Yeah.
Great. Thank you. Thanks for all this information again. Well, I'm sure there will be many more topics to talk about as the industry grows and the volts and the watts and pretty much everything is growing on the solution sets. And once again, John, thank you very much for sharing all this information. And
My pleasure. Thank you, Kerim.
hope to see you in a future conversation. Thank you.
Sounds good.